Okay, sixth grade. So this is Unit 1, Lesson 10. And looks like it's page 85. Here we go. So it says on the grid, draw a triangle with an area of 12 square units. Try to draw a non-right triangle. It says try. You don't have to. Be prepared to explain how you know the area of your triangle is 12 squared units. Well, you guys should be becoming pretty familiar with the formula for the area of a triangle. Area is 1/2 the base times the height. Let's forget the 1/2 for a second. What number, because remember we want to double this because it's going to be times 1/2. So what two numbers could we use to get 24? Because 12 is half of 24. What two numbers? Yeah.
You could use 8 and 3.
Okay, 8 and 3. So let's do that. So I could draw a triangle with a base of 3. 1, 2, 3. I'm going to do 3 right here. And then up 8. 1, 2, 3, 4, 5, 6. Oh, man, I blew that. Let's try that again. Let's go down here a little bit lower. 1, 2, 3. And then I want to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go like this. 1, 2, 3, 4, 5, 6, 7, 8. And I'll put a 3 there and an 8 there. And so that would be area equals 1/2 times 3 times 8. Excuse me. And so 8 times 3 is 24. Half of 24 is 12. So it's 12 units squared. All right, there you go. Now, you guys may draw something a little different.
I didn't do a right triangle. I did a...
That's fine. That's fine. Okay. All right. Hunting for heights. Now, this is similar to what you guys are going to be doing in the Get More Math. I mean, that'll help you guys figuring out the heights of some of these. It says, here are 3 copies of the same triangle. The triangle is rotated so that the side chosen as the base is the bottom and is horizontal. Horizontal means left to right. So I'm just going to highlight A right here, which is the base in this one. And here's the same triangle rotated. And this is the base here. And then just so we're all clear, here's the base in this one. So then it says, let's see here, draw a height that corresponds to each base. Use an index card to help you. Well, I didn't hand out any index cards. All of you should have a protractor. And if you don't, then you're just going to have to wait because I've got a few extra, but not right now. So what you want to do, from A here, we want to go to this point right there. And you can see if you look at your protractor, and let me zoom in a little bit here. You can see on your protractor, there's a couple lines right there that'll help you make something perpendicular. I'm going to lay the base right on there, and I want this line to pretty much point to the top vertex there. And so I'm just going to do some little dashes. And that would be the height. Now for B, what's the height of the triangle? It's going to be right here. So again, I want to get something that's going to be perpendicular to the height. That looks about right. And I'm just going to do some dots and dashes till it looks just about right. Okay, so that would be the height. Not quite right, but pretty close. Okay. And then for C, you could do the same thing. What's the height for this one right here? So I want to draw a line that's perpendicular to C. That means it's going to be at a right angle. And I could start it anywhere along here. It doesn't really matter.
You could start it on the other end.
Yeah, I could start it way over here. No reason to, but I could. And then I'm just going to make some marks till it looks like it's just about the same height.
Couldn't you do it on the where point A and B meet? Couldn't you do it on the outside of that?
Where point A and yeah, I could extend it this way and go up that way. Yeah, as long as, because no matter where I go along this line here, when I draw a right angle and stop at this point, it's going to be the same height. Maybe I'm doing it right here. It's going to be the same height. Maybe I'll do it way over here. It'll be the same height. Okay. Yes.
Is base always on the bottom?
No, what a good question. The base is not always on the bottom. And so let's look at page 87. And page 87 has all kinds of examples. And you can, hang on, one question at a time. You can see, and they've named the bases here, and I'll just highlight the first couple in red. So in triangle A, there's the base. In triangle B, here's the base, and they're naming them for you. And then the base for C is right here, and so forth. So the base is not always on the bottom. So it says draw a line segment to show the height for the chosen base in each triangle. Now, remember, going back to that first example, oh, no, that wouldn't work. I was thinking of another lesson from 7th grade, I think. You want the height. So for A here,
Isn't the height the highest point on the
opposite the base. It's the highest point opposite the base. Okay. For A, it'd be right there. For B, it'd be right here. For C, where do you think the base would be?
Oh,
right there. Okay.
You mean
So
the height?
it's the point or the highest point opposite the base or the vertex. Vertex is the corner opposite the base. So here's D. Here's the base.
That's a right angle
What's the height? Yeah, this one's a right
on the top.
triangle. Yeah, a right
Yeah,
angle.
Right
Right
there.
there.
And depth is also one also.
And then here's the base here. Okay.
Oh,
But you guys, it says to draw a line segment to show the height. So I'm going to do E, for example. So this is the highest point. So it doesn't really matter where. I'll just pick right here, for example. And this is going to be the height. Okay.
So it just has to be.
It's the highest point opposite the base. Here's the base. So what's the highest point opposite the base?
Right at the corner.
Yeah, that vertex. If it helps you, you could kind of turn it and think about it this way. All right. So, and it says some bases are better than others. How are we doing on time here? Okay. And not much time left in class. All right. It says for each triangle, identify and label a base and height. If you need to draw a line segment to, if needed, draw a line segment to show the height. So turn the page. We're on page 88 now. Okay. Well, they're letting you choose. I don't know. A, it'd be easy. I would pick this as the base. And what do you think the height would be? Let's go right there. Nice right triangle right there. How about B? What could we use for the base for B?
The
Yeah.
One, the bottom one.
Yeah, you could use the bottom one, but you could also use the top one. So, for example, if I use this as the base, let's say this is the base right there. All right. What would be the height? Right here. And then I'm just going to draw a line to show the height. And I probably should have, just to be clear, this would be considered the height in that one. Okay. How about C?
Oh, ooh.
This could be the base. What would be the height? Way over here.
It kind of looks like a party hat.
Almost looks like a party hat, yeah. So for the height, I could just go like this. How about D? And these will be 4 good examples for you guys to use. I could use this for the base. And the height will be right here. And then I could just draw some marks to there. All right. I'm not worried about this. What you could, just cross it out. What you could do is eliminate, there's 3 triangles, 1, 2, 3 on the outside if I was to extend these lines. So there's a triangle right there. There's a triangle right here. So I call this triangle 1. This could be triangle 2, and this could be triangle 3. And then you could subtract those from the overall unit, which is, I think it's 12 by 12. And then that'd be 144. And then what's left over would be the shaded area. Anyways, lesson summary, you guys know what those are. They're not asking you any questions. But this is where they talk about index cards. But again, I wanted you guys to just use your protractor. This is just an example. And same thing on this page here, more of the lesson summary. But now here are your practice problems. And so you guys are to do pages. Yeah, 2 pages. Let's see here. To 93. Is it 85?
Yeah.
85 to 93. Okay. And all right, one more thing I'm going to show you. It says, find the area of this shape, show your reasoning. Take a look at what I did here. I used some transparent paper. And if I cut out these 2 little triangles, I have what? A parallelogram, right? You could figure out those, or figure out that one. Now, and then I could cut out one of these triangles and put it with this. And then what do I have? I have another parallelogram, right? If I put those 2 triangles together. And then you would add up this one and this one. And then you would have the area of the shaded region. See if you can do that. Okay. This is similar to the one we were talking about at the very beginning. It says, can side D be the base for this triangle? Sure could. And if so, what length would be the corresponding height? Obviously this. G would be. All right. All right, I'm going to end that video.